I'm not going to be presenting myself, but for those who are joining us on Teams, I'm going to be, of course, saying very basic about myself. I'm Leila Lomashvili, Associate Professor of Linguistics and TESOL. I'm here at English and Humanities Department, and today's presentation is focused on how brain second language learners is enriched by second language learning. And we're going to be also discussing some additional things in our presentation as shown in the first slide. First of all, we're going to be reviewing basic features of animal communication versus language, how different we are from our closest ancestors in evolutionary development, like apes. And then we're going to be also discussing what happens to the brain and brain areas in general, as well as the genes involved in language processing. And besides that, we will be, of course, covering in the bulk of this presentation how second language acquisition proceeds in terms of the phonology, morphology, syntax, semantics, as well as pragmatics a little bit. In the middle of our presentation, I might be also focus a little bit on socioeconomic status of the families and communities and how it affects the way the kids are acquiring their second languages. And towards the end of the presentation, it's going to be probably the most intriguing part, which is about stem cells and how they are kind of revolutionizing what we think about language learning is, and how we can also help people who are affected by various strokes and lesions in their brains to recover their languages, as well as the second languages and things like that. So towards the end, I'm going to be also touching on the pedagogical approaches, because this is something that we always need to remember as future teachers, and have these all this knowledge put together in order to make the informed decisions about pedagogy of second language teaching. Okay, now starting from the language evolution, we need to remember that even our closest ancestors in evolution development, like apes, and in this case, we're discussing the vervet monkeys, they don't have the same kind of communication system as we do humans. It's understandable because there are lots of linguistic knowledge that is inaccessible to these species, and specifically many scientists have proposed that it's the part of the linguistic knowledge that they don't get is, of course, the syntax. So syntax is kind of what defines us as a unique creatures. And even in Chomsky's thinking, syntax was defined as a core of the linguistic knowledge, and how human kids, when they start developing their basic production skills in the first language, they, of course, start also figuring out how to connect the words into larger units, like phrases and into the sentences, and learning all these rules along the way. So we also need to know that, for example, vervet monkeys have a very sophisticated call system for different kind of calls. For example, in the book that I read to prepare this presentation by Dr. David Sosa, he talks about that they make different calls for snake, for leopard, and eagle, and each of them is warning their account specifics in a different way, what kind of threat is coming, and they're prepared for that enemy to be able to ward them. Now, Kenzie was another, probably the smartest bonobo. And bonobos typically are even closer to human beings than vervet monkeys. And he was able to memorize and to learn and also connect in the phrases as well as in the sentences, the things like several thousand lexicograms. And lexicograms typically represent the whole logographs, and logograph stands for the whole word in a language like Chinese. And one symbol, the whole word. So that type of alphabet has a very specific kind of processing, and we're going to be discussing this later on in this lecture. One of the interesting things about the human language development, guys, was also the ability to produce discrete sounds. And discrete sounds is something that was possible to be altered by the mechanism that we see in this picture. For example, the larynx was one of those organs that underwent probably the greatest changes in evolutionary development. And it developed and became much bigger. And it lowered also when the humans started walking upright. And we have Homo erectus, the species that emerged in the evolution development of humans, and they started producing the first sounds. Now, first sounds, of course, is not language yet, and there should be also the mind prepared for that type of readiness to produce the language. So it took, of course, centuries and centuries of development to develop the ability to produce the string of words as well as the string of sounds, which form the words. And the interesting thing about also about these terms, and especially the production issue, guys, the discrete sounds could be produced also by parrots, but they don't have the brains, of course, that humans do, and their utterances are often meaningless, although they are able to repeat the same way as human beings can repeat and form their utterances. So another interesting and big milestone in the development of language ability was FOXP2 gene mutation. So this happened along the way when dietary changes came to play in Africa. As we know, the human beings emerged in Africa in the middle of continent, and so this gene underwent mutation because, as I mentioned, dietary changes, and then the language ability kicked in, and very soon after that, and geneticists believe that this enabled our species to create the precise speech. The same gene, by the way, is also responsible for a variety of the language deficits, but it's not just the language. It also, this gene also is responsible for a number of other interesting things in the human body. But one of those probably most focal and highly defined functions of these genes, of course, affecting the way how the human beings are acquiring their functional morphology. So there's a family named K family in the UK, who the entire language were affected with mutation, and they were unable to produce and even acquire like a functional morphology in English, like S at the end of the third person singular, or the, and those kind of prepositions and other things which have to do with functions, but not so much vocabulary itself. So referential meanings are in a different parts of the brain. They may not be affected the same way as a functional morphology, and we're going to be clarifying this later on. So the first discovering the brain studies started in the 19th century, and the guy who came up with a very, very interesting observation was Rock. He was a physician, an Austrian physician, and he discovered the area right here, which, if it would be affected by the lesion in the area, we would have the patients who could face enormous difficulty to produce a coherent speech. It's not even coherent, but even difficulty of speaking. but they would make a complete sense. It's not like, for example, meaningless or kind of gibberish that we might be listening to a person, which is the case in the Wernicke's um, aphasia patients. And I want to show you on the picture, Broca's area is on the left-hand side, and Wernicke's area is down below in the blue color. And you should be able to see that whenever these areas are affected, we have Broca's aphasia, and we also have Wernicke's aphasia respondingly, and each of these are is affecting the language in a specific way. Now, first of all, in Broca's case, by the way, it was the difficulty in the production, as I said, but in Wernicke's aphasia, we see that whatever the patient says doesn't make any sense. Although they have pretty well-developed syntax and they talk a lot. Sometimes even cannot stop talking. And this type of like a deficit is called Wernicke's aphasia, and it's a pretty famous one, by the way, in linguistic circles. Now, besides these two areas, there are also multiple neural networks that are involved in language processing, and you need to remember that some of these neural networks are specialized in certain kind of categories in grammar, which is really surprising. For example, if some of the kids are hearing, let's say, nouns, they can be activating a different part of the brain, and when they're hearing the verb, they can be activating a different part of the brain. So acquisition might take a pretty uneven path. And we see this at the beginning of language acquisition. It's all infants always acquire the nouns, first of all, that have very concrete referent. In other words, we can name, for example, this is a table or a chair or a candy and things like that. But afterwards, when they start producing the verbs, that's all completely different level of language acquisition. So they are served by distinctive neural networks in the brains. Okay. So in the sentences more complex, that's a very interesting finding, by the way, guys. Both Broca's and Wernicke's area were in the left hemisphere. So you shouldn't be ever thinking that anything is processed in the right hemisphere of the brain related to language. But I'll be explaining in a minute how the right hemisphere also participates in the language processing, and in what cases they're more active than. So more complex the sentence structure is. Right hemisphere is going to be involved in understanding and processing that sentence. Okay. Now, Wernicke's area is a part of the left temporal lobe, as I explained before, but I also want to say that emotional content of the language is located in the right hemisphere. So that's something that is pretty interesting, because we know that women are much more endowed by the ability to understand this emotional content behind the words. And so in the next couple of slides, I'm going to be showing how women's processing is different from voice processing. So the 2078, there was an additional discovery, guys. Besides those two traditional areas in which the language is processed, like Broca and Wernicke, cerebellum was also found to be very well involved in language processing. Temporal lobe is part of cerebellum. You can safely say, okay, this is a part of the area that could be also involved in this. But the additional evidence came from PT or in EG studies, electroencephalography, when these scanning technologies came to the use in linguistics. They became kind of detectors in which part of the brain these neurons are firing, and how, in what part the language is processing the specific component of language. For example, syllables and tones. These are the things that are processed in one particular area in 16-month-olds, when they listen, but they cannot produce and they're not yet like language producers, active language producers, they still are able to process this in a specific area of the brain. But the elements are processed in a different areas of left hemisphere, although there was also some right hemisphere activity. And I'll be talking about this a little later about the tones, because typically syllables or vowels could be in one area and the tone is a different area. And in Chinese is one of those examples. Now, I want to quickly mention that mutated gene, guys, that was mentioned earlier. It could be also affecting some of these previous things like syllables and tones, production of these two elements, and patients who are affected by some sort of mutation that may not be able to acquire this feature successfully. And the other important area of the language that is connected to the acquisition of the vocabulary, in particular, is gesture. So when at the early age, when children are babbling, and even before babbling stage, when they are gesturing, this could be a very big predictor how the child is developing vocabulary at a later age. And I was really surprised about this kind of correspondence when I saw this study earlier. So they show that, for example, at the age of 14, what the child is, how child is gesturing, it could be a very good predictor of the vocabulary at the 42 month. And this type of correspondence is again, of course, due to the areas of brains we discussed, and it's interesting to know that sometimes when this kind of seamless development doesn't happen, we need to observe whether the child is doing the gesturing or not at a certain age, and possibly go to therapist and take the child to the therapist if they're not doing the things whatever normal children do. Now, fMRI and language processing. This was probably one of the most interesting parts in the source I read. They compared Chinese and Spanish bilingual kids, and they found that Chinese, both of these kids are processing their languages, of course, in the left hemisphere. But there was something else going on in Chinese kids. And they did a later study, and what they found was that they showed additional activation in the right temporal and parietal lobe regions. So right temporal lobe is in the right hemisphere, guys, which has to do with creative, intuitive, artistic, nonverbal, or image creation type mentality. It's very different from analytical part of the brain, which is the left hemisphere. So why is this happening? How these Chinese kids are different from regular kids? That was a question I was kind of intrigued with. And so one of the idea that underlies this is the logographic alphabet. So when the kids are learning the logographic alphabet, they're storing the entire language information in terms of the images in their brain. And this activates right hemisphere's visual processing areas. So they store the word in their brain in the visual processing area, which is in the right hemisphere. So that's a part of their language in their writing system. And it was kind of fascinating to see that the kids who activate, Chinese kids who activate this right hemisphere in addition to the left hemisphere, possibly have some kind of course, consequences in terms of like creating images and other things in their lifetime. And it's easier for these kids to be able to create with like new things, or generally come up with image making ability later on in their lifetime. So what we need to do in order to be able to kind of compensate this kind of lag in left hemisphere languages, like, for example, English and others which have only like phonemic alphabets. Most likely we need to teach them poetry in the kind of rhythmic to activate their right hemisphere and compensate with this kind of lag. So they already have it, while our kids need to have this kind of teaching, right? Additional area of knowledge. Now, there was also another kind of confirmation of the same thing when they looked at the two different alphabets in Japanese. And on the top, guys, you see it's a hiragana, the more modern alphabet, which corresponds to syllables. And on the bottom, there is a kanji, which is old logographic Japanese alphabet. And it was only kanji that activated the right hemisphere. So again, whenever we see this correspondence between the whole word and the logograph, they're storing this in a different, and it's right hemisphere that helps to recall this type of knowledge and create the sentences, connecting these small things to each other. And we don't have the same kind of processing going on in hiragana, which is based on the syllables, because syllables don't make a sense. They are not stored in the same area of brain. It's a left hemisphere. Okay. So another, tone and vowel sounds. And this is Green et al. And Liang and Van Hu in 2004. They studied and compared these two elements in phonology of young kids, and they found that brain area that processes vowel sounds is different from the one that is processing tone. Although tone is directly connected to the vowel, right? And it's surprising because it's additional knowledge, and possibly kids are getting the tones much later in their development than pure vowel sounds, because vowel sounds possibly could be like a part of the genetic dormant as a humans, but tone is something learned afterwards. Now, the expression monkey see, monkey do is probably the most relevant one if we're going to be learning about these mirror neurons here. So, what are the mirror neurons? They're kind of reflecting something else, possibly, if you want to explain them, but it's not entirely like this. These are the neurons that are involved in execution of certain kind of movements. And whenever the kids are seeing, let's say, the person moving or walking and in the room, and mom is saying, okay, daddy is walking. And when the kid is looking at the daddy, they can be firing these mirror neurons in their head, and separate from Wernicke's area and the other areas that we discussed before. So these mirror neurons, guys, is kind of specialized area in the brain, which are processing the human movements, and they're helping kids to acquire the verbs' meanings, and especially those verbs that have to do with some kind of movement. Even the words like heat or punch or those kind of verbs are going to be firing mirror neurons rather than like regular parts of the brain. So just additional thing to know. And gender differences, this was another very cool thing to discover. And so male and females, of course, they process the language in the left hemisphere predominantly. However, women are dual processors. So what that means is that we tend to do much more in both hemispheres than men. So what that means, why this is happening, guys? Corpus callosum, that's the area of two hemispheres. And you can see these are the two. It should be located somewhere along these gyres. That's the area of the brain that is specializing connecting rather these two hemispheres, and it's much thicker and all developed in females than in men. Most likely this happened due to evolutionary development. Possibly there was some hormones and other things involved. So women have much bigger corpus callosum, and because of these neural networks connecting these two hemispheres, we have much more activation in women with the right hemisphere than men. But with some caveats, and I'm going to be explaining this a little later. Now, this corpus callosum is the one that hardens at the age of puberty, and we are getting much harder time for the kids to acquire the second languages after this age than before this age, right? So the puberty is kind of dividing the line for the window of opportunity to acquire the second language and being able to easily produce the second language. Now, dual hemisphere language advantage, sometimes we call it, not just processing, becomes why most young girls acquire spoken language easier than most young boys. And boys are typically processing their language in left hemisphere, while girls are uh, involving both hemispheres in their language processing as well as in production. So, processing. That's a very interesting part, guys. Again, reading cadence, and pitch. These are the things that there were a number of people who said that from birth, kids are processing these sounds, and possibly the pitch, mother's pitch is probably the most prominent thing they pick up. And the other important development stage is babbling. And in doing babbling, we see that the kids are producing things and the kind of sounds that they've never heard in their environment. And we're surprised. How do they say the things like that, right? So this is what the pre-programmed and genetically endowed mechanisms are doing to our brains, and the kids, they start the very first stage of babbling, they're going to be producing all of these sounds that they don't hear in the environment. So it's an entirely genetically imbued kind of program in their brains. So within a few months, pruning of the phonic networks begins, and around 1 year, the surviving neural networks focus only on the ambient language, and they're no longer able to differentiate foreign sounds in the second language to the same extent as in their native language, ambient language. So this is what accounts after the age of 5. If we're going to be introducing the second language after the age of 5, they're entirely specialized in the first language, and they're going to be ending up with a very thick accent. That's the result why the kids, even after the age of 1, this ability decreases. So the second language perception, as well as the production of those distinctive sounds, drastically worsens because of the specialization of young brains on their ambient language. Okay. Now, vocabulary and socioeconomic status. I want to touch this on, though not directly related to brain, but I feel it has to do with a lot with socioeconomic status of the families in which the kids are raised, and especially in the second language, it has also a big effect. So the upper middle class families, the kids at 3 years of age, they have 1,116 words of vocabulary. It's an average, of course, because they studied about 42 kids, and from 7 to 9 months all the way to the age of 3. And they found this kind of very, very high percentage of vocabulary, high, well developed vocabulary in the kids. This family had a high socioeconomic status. While in the middle, we have 749, and the welfare family and their kids, they have much lower level of vocabulary. So what happens when these kids go to school, and how schools need to compensate this kind of deficit and get them school ready? And this is what I want to show, because there's some school libraries and several states that have birth to school programs. they're a specific kind of staff trained in the schools to connect to the families with low socioeconomic status and provide them with all different means for the kids to start learning and develop the vocabulary along their peers who are more fortunate. So having these type of additional programs, of course, this is a huge thing in our country. And okay, that's the thing that as teachers we need to be aware of and try to connect to more families and be able to provide these kind of resources. So low-cost, age-appropriate resources to use with children during the preschool years is very important during the child's vocabulary development before they enter the school. Now, for the syntax, I want to give you some very basic background. I don't want to tire you too much. When the first word emerges like candy or up, the just word like up means pick me up, right? Or candy, give me candy. And afterwards, at the three-word stage, we see that there's a so when they say give me candy, this is unfolded syntax. So at this stage, children can do much more complex things like construing the entire sentence. There's going to be an agent to the sentence, will be verb, predicate the full thing, and it's going to be like a well-developed language. Now, how does the meaning development happen? And in such a short period of time, like 1/5 of a second, the kids are capable of processing the meaning of the sentence and immediately responding correctly to whatever input they have. So there's primary studies in psycholinguistics, and those primary studies, guys, are using prime and the target, two words that could be presented to on the computer screen to the test taker, and one of them is going to be related, of course, to the meaning to whatever the target is, and they need to identify whether the target word is a possible word and what the meaning of it is. Whenever they have similar meaning, like goose and swan, the recognition of these kind of related words happens instantaneously. It's very, very quick. And as opposed to, let's say, tulip and goose, for example, tulip and swan, because they come from very different kind of domains of knowledge, or possibly they belong to different types of things, right? So there was a massive study that showed that these related words are stored in the same area of the brain. For example, swan and the goose is going to be in the same area, and kids are going to be recalling these words much more easily when they're presented together as opposed to unrelated words. For example, if you're going to be giving the examples of, say, things, persons, animals, and tools. So tools, you're going to be giving the example of two different tools. They can be recalled easily, but if you'll be giving the prime of the person and then target is going to be a tool, that type of recognition, of course, is going to break down, and it's going to take a much longer time to recognize the target as a word, possible word in English. So what does it show? So our brains are storing the similar information in one particular area. And that area, of course, is going to be specializing with the neural networks in that type of vocabulary. Now, on the right-hand side, guys, you see there's a structure showing how the tense is processed and the sentence, the full sentence, like horse eats the hay. And there was remember Pinker? So in his paper, Pinker said, okay, we arrange our thoughts in phrases, And on the left-hand side, you see the horse, which is noun phrase, and when it combines with a verb phrase is much more complex than noun. So processing of the verb phrase might take a little more time than the noun phrase, right? Because verb phrase contains the verb eat, and the hay is going to be the complement noun phrase, right? Which we'll call object. So these processes, verb phrase and noun phrase, combined together, still it's so efficient and so quick processing of this kind of information. Might be surprised, how could the neural networks do this kind of thing in such a small, short period of time? And there were also some interesting findings, especially in the semantic processing. For example, when there was the dog chased the cat and the cat chased the dog. These are two very different things, right? In this picture, I have one scenario, but not the other one. It takes approximately the same time, but they need to think about a little more when the second sentence is presented, and they need to also process with the agent, right? In other words, the roles of the subject plays a crucial role, and there's a difference in meaning between these two sentences, and it's going to be the second sentence production is going to be delayed a little bit than the first sentence, okay? Which is kind of typical until they figure out what the syntactic role of the dog is in one sentence as opposed to another. Now, where this area is the one that was active when there were two different semantic possibilities. For example, car is in the garage, and the automobile is in the garage. So automobile was processed a little slower than the first one, because there's a difference again in meaning between car and automobile. So now the remaining questions for the remaining part of the presentation are the brain of bilingual is different from monolingual brain, and are the two languages processed by the same areas in the brain, or they are related and processing? Let's say one language is one part of the brain and the other one another part of the brain, or we have them in the same area. So we'll be trying to answer this. And how does the processing areas interact when the person is shifting from L1 to L2? That's another question. And if when there's a acquisition of two languages too early, like for example from the age of 3 or so, how does the child process the first language as opposed to the second language, and whether the first language is going to be affected by the second language, and might be delaying the acquisition of the first language. And we're going to be answering no. Yeah, everything goes seamlessly. Okay, now Colin, and that was one of the very, very interesting one, guys, in addition to what we said before. So he tested 10 monolinguals as opposed to 11, right? And he found that both of these groups were processing their language in left hemisphere. That was the dominant thing. The Broca's area, that's the dominant area. However, when the bilinguals were simultaneously processing each of their two languages and switching from one to the second language, from L1 to L2, they showed increased brain activity in the right hemisphere. So he was kind of intrigued. What's going on? Okay. So why is, let's say, the kids switching from one to another language, and they need to activate two hemispheres? So he did a follow-up study and showed much more interesting results. So the right hemisphere involvement in the processing of L2 was found among the people who acquired the L2 early on in their development as toddlers. So the toddler age was somehow more conducive to the activation of the right hemisphere than the later age of second language learning. So this happens regardless the degree of fluency in L2. So the kids are kind of machines, very efficient machines, and if they are given the second language opportunity early on, they should be able to acquire the second language with a different kind of mechanism. And this is what afterwards the common called bilingual signature. So the kids who start learning their second language and environmental exposure is as early as, for example, the age of 3, 4, or so. They're going to have much more activation in the right hemisphere when they process the second language, and they will be switching from language to language more efficiently than the kids who acquire the second language later on in their lives, let's say after the age of puberty or so. Okay. Now, does L2 delay L1 acquisition? We said no, and studies have shown that L2 is acquired simultaneously with L1, which was seen to acquire them with little or no impact. Now, no impact, what I mean, guys, is that we already talked about phonological acquisition, right? And it's age sensitive. If we're going to be delaying, let's say, language introduction after the age of 5, then they can be ending up with a thick accent. That's was one of those kind of catches we said earlier, but not a big deal because they are still pretty comprehensible to people when they are producing the language. But still, there is some effect of the age on the way how people acquire their final state or get to the final state of the second language. Right. So phonology of L2 is easy before the age of 5, and then later on it gets a little. However, all of the entire language can be learned even well after age of 5 or even well after age of puberty, because many people end up with a fluency in the second language even without this much. But true bilingual signature is among the kids who start early. That's one of the discoveries that I found. Yeah, until recently, we also want to talk about these stem cells, as I mentioned at the beginning. So we know that whenever the brain is affected with some kind of severe disorder, let's say lesion in the left hemisphere, some of the neurons die, right? And the idea was that they cannot ever be recovered, but it appeared to be wrong, and it's good. Okay. So in the brain, they form stem cells, but stem cells are all over the body, guys, in other areas, of course. So what the scientists found is that if the certainly area of the brain is damaged, and we're able to inject some of the stem cells within that injured part of the brain, they are able to re-specialize and become more specialized in the language. However, don't be kind of tricked by the fact that this is kind of panacea, or it's going to be solving the entire issue of, let's say, second language, and people are going to be recovering their second language easily. Because there's a limit how much and what kind of stem cells you can inject, and possibly they can be specializing and restoring the ability to speak in the second language as well. So in the preclinical studies, they found that brain plasticity is not limitless, but they can drastically improve language function, which is good still. And research is ongoing, and we might find even more. So preclinical studies of diseases that affect language, such as stroke, they show that these smart things like stem cells could be used to develop the ability to restart your language and be able to produce even some severe impacts. So, implication for pedagogy, and we're wrapping up. To knowing all of these facts about how the brain is processing the language and how different hemispheres are involved in language learning, we need to start planning our pedagogical activities with this kind of background knowledge. It's not something that is going to be useful, let's say, in every day when you go to class and you need to write your lesson plan and prepare the materials you need, instruction. But this knowledge is absolutely essential for the future teachers because, again, it tells them there are some limitations and also there are some opportunities, right, for the young kids in a certain age, how they process the language. And then when the children arrive late to the country where L2 is spoken, it is important to keep this information also in mind because you cannot teach them, let's say, from the very beginning, the very complex things that is inaccessible for their current level of development, and possibly we need to think in terms of the milestones, like cognitive milestones that they achieve throughout their development, possibly plan instruction based on this type of knowledge combined with the development of milestones. So that's going to be one of those prerequisites that we need to think about. Teachers also need to consider the differences between academic and everyday language. We know that everyday language is easy to acquire. It takes about like a year or so, and to become pretty functional and being able to produce the language after a year of exposure, especially in the school setting where there's lots of interaction between kids and teachers. However, academic language development is a lifetime process. And we need to, of course, think about that it takes much longer time, and the school appropriate planning needs to be implemented in order to be able to teach them most effectively, right? So we sometimes say, okay, standards are things that we follow. However, standard is not everything. Still, we need to be a little more proactive in presenting more challenging materials that were even for the current level of development by the kind of approach we learned in this course, I+1. So trying to get ahead of time and give them a little more challenging materials than whatever standards sometimes dictate. Now, any child can acquire L2 without repercussions, but the school personnel and teachers show empathy, humanistic attitude to them, and respect to EL's cultures. They feel that teachers don't have this kind of empathy, or they think, okay, oh, they're not going to be able to learn the same way as the mainstream kids. Let's say they're not as smart as the mainstream. That's not the kind of approach. Even any child can learn, any kind of child can develop the same kind of knowledge as any public student. That's all I wanted to say today. Thank you.
Can I ask you a question?
Sure. Go ahead.
So one of the things that I've heard, and part of the question is asking if your understanding of the research supports this, but you're talking about language learners who start exploring a second language very young in life and the benefits of that. So one of the things I've learned in the context of heritage speakers, so people who grow up with two languages, maybe one language in the home and one language outside the home. So children of immigrants, for example, is that they can become 90 to 95% fluent, or some like high level of fluency in both languages, but there's always just a little bit in both languages, maybe some specialized terminology or things like that, that they can't quite get to. So is that true? Have you seen evidence of that in the research?
Yeah,
and if that's the case, is that a brain-based function or is that like a social function?
Very good question. Now, there's a large amount of evidence saying that in the second language, bilingual learners, especially those who are acquiring both languages from birth, possibly, and the kids who are processing two different languages at home, they're going to be ending up almost 100% in both languages. It's not like they get 95% or so, given what kind of conditions they're in. Depends on the school, family, status, a bunch of different things. In first language, typically, which is dominant language in the early language in their development, right? They are going to be developing 100%, regardless who they are. Even like a child of a very impoverished family is going to be getting the 100% grammar as well as knowledge of their native language. For the second language, that's always like, it depends on the environment. You can get to 100% in the second language if everything is favorable.
Okay.
Especially for the kids who are born here and they process both languages.
So is the home language considered the first? So for example, I have a friend who's from China and she has a child who was born in the United States. And so Mandarin spoke primarily at home and English everywhere else.
The very first language that the child starts processing before they are exposed to the second language outside of family nucleus. So that has a kind of unique function, and it's going to be always the first language. However, if there are rare cases when the kids, especially those who come here young, the age of 5 or 6 or so, and family gives up talking in the first language in home, and the kids are shifting to the second language completely. Those are who are developing in a very different way because they're going to be developing the second language like their first language. And deleting their first language. And this is called subtractive bilingualism, which is really bad because cognitively they're going to be functioning like monolingual kids.
So from a language development perspective, if your native language is different than the language that you're surrounded by, it's actually probably better to speak in your native language with your child and let the child experience
and develop both languages simultaneously rather than deleting the first language.
Gotcha.
And some parents don't even know that this bilingual signature is an advantage. They are trying to just teach them just English, for example, in this country, and they're saying, okay, if they delete the first language, it's even better for them. And they have no idea that they are depriving the kids to develop really much better competence in both languages, right? Because their brains are going to be different. Bilingual brains are always better than a monolingual brain because they have more awareness in their first language as well. Because if they learn the second language, guys, your first language knowledge is going to be 5 times better. It's kind of rough comparison, but you know your first language better if you know the second language, even if it's a partial knowledge in the second language. So in time, you need to encourage them to learn as much as they can. Don't press. Don't pressure. In other words, and don't give them a hard time learning the second language. But still, it's going to be 100 times better for them cognitively than just having only one language. Awesome.
Thank you.
So, you're so welcome.
Well done, Professor.
Well,
Thank
you. I appreciate it. But, this was just the first 2 chapters in the text I found, and also some additional stuff about stem cells and some language processing.